Hello boys and girls, Mr. Poole here again, and today we're going to practice another kind of work with fractions. This time, what if we have to multiply and there's mixed numbers and fractions? Once again, we started with a word problem that will help us think about when this might really occur. So, my family took a car trip that lasted 3.5 hours. I read for 3/4 of the trip. So how much time did I spend reading? You can see, like before, I've already annotated all the important quantities, relationships, and I've underlined the question. So the important quantities, there's a car trip that lasted 3.5 hours. And another important quantity, but it's also a relationship, I read 3/4 of the trip. So 3/4 is related to that 3.5 hours. So those two are important amounts, quantities. And then the question is, how much time did I actually spend reading? So we're going to think about this first in terms of how can we represent it with some kind of drawing. And we're going to go back to our model as we used before. And we got to think, we're taking a piece of what, 3.5. So first I'm going to have to make 3.5. 1, 2, 3, and I'm going to show another whole 4. I'm going to cut them each in half. 1 hour, 2 hours, 3 hours, and a half hour. So here's my 3.5 hours, goes right up to here. Okay. And I'm going to put, since I went up and down, I'm going to make these up and down lines. Vertical lines. No, I'm not. That gets confusing. I'm going to make my diagonal lines. My 3.5 hours. Let's get a little neater. Next, I read for 3/4 of that trip. 3/4. That means I'm going to cut each one into fourths. 1, 2, 3. 1, 2, 3. Gives me fourths. 1, 2, 3. Gives me fourths. And 1, 2, 3. It gives me fourths. Now, 3/4 of those. 1/4, 2/4, 3/4 of this hour. So I'm going to shade it down to my 3/4 line. 1, 2, 3/4 of an hour. I'm going to shade in down to my 3/4 line. 1, 2, 3, 3/4 of an hour. I'm going to shade in down to my 3/4 line. And 3/4 of an hour. Now I only have this side, so I'm going to just that much. Oops. Okay, that was like that. Okay. So, what does this show me? 3.5 hours, and then I took 3/4 of it. So, what did I do here? Well, now look at each whole. Each whole is now divided into 8 equal pieces. So we have 8ths, and in this one I have 6, and in this one I have 6, and this one I have 6, and this one I just have 3. Now we've all added fractions before. So we know we add the numerator. 6 plus 6 is 12. 18 plus 3 is 21 eighths. Which is the same as, well, let me see, it's 8/8 plus 8/8, it's 16/8 plus 5 more eighths would be 21/8. And so that's the same as 2 wholes and 5/8. Okay. Now, as we've said before, you can multiply these numbers as well and get the answer. And it's a little more time efficient. We're going to show you, though, we're going to go back to an old method of multiplication, if you remember, using the area model with whole numbers. And I like to put my largest number, if I can, to the top. It really doesn't matter. It's 3 plus 1/2. If we decompose that, we have 3 wholes and 1/2. I made this bigger because 3 takes up more space than 1/2. It's a greater quantity. Now, the other factor is just 3/4. So, if you remember, we do 3/4 times 3, and then we would do 3/4 times 1/2. Now think back to our first lesson. This would be the same as 3/4 times 3 wholes, which would give me 9/4. And this would give me 3 times 1, 4 times 2, which would give me 3/8. Okay. Now, we've done this before. We know we can't add fractions unless they have the same denominator. So, what denominator could 8 and 4 both have in common? And of course, 4 is a factor of 8, so we're going to change 9/4. How we get equals how many eighths? 4 times 2 equals 8, and so 9 times 2 equals 18. So we have 18/8 plus 3/8, and again gives me 21/8, which is the same as 2 and 5/8. Now the other strategy we want to show you, strategy number 1, strategy number 2, and then strategy number 3, which is even a little more efficient, is if I have 3 and 1/2 times 3/4. Remember our first rule, change everything into a fraction? Well, 3 wholes would be 6/2 plus 1/2 would be 7/2 times 3/4. Numerator times numerator, denominator times denominator. Which one do you think is more efficient in terms of time? I hope you pick this one. But these are other ways to understand that there are other ways to get the answer besides this. When you get good at this, this becomes the most efficient way to do it. Okay. Next time, mixed number times a mixed number. Until then, remember, math is everywhere.